Good morning, student, and welcome back to all of you in the previous class. Already in the previous session, I have completed chapter number 11, that is Electricity and Magnetism Part 2. Okay, and only few topics was left. Okay, and the last session, what the thing I have explained is that is elements of Earth magnetism. Elements of Earth's magnetism. Okay, so I have already explained that there are three elements of Earth's magnetism. First one, angle of dip or inclination. Angle of inclination. Okay, second one, angle of declination, and third one, horizontal components of Earth magnetism. Okay, there are three elements of Earth magnetism. Angle of dip or angle of inclination, angle of declination, and third one is the horizontal component of Earth's magnetism. Okay, these three topics already I have explained in the previous class, as well as also diagram also explained. Just see once more the diagram. Okay. This one theta and this one phi. Okay, this one is the angle of inclination, angle of inclination or angle of dip. Okay, this one is angle of declination, angle of declination, and this one is geographic meridian, and this one magnetic meridian. Okay, and this one is the magnetic needle. Okay, so how you can define one by one? I am going to explain. Angle of, if any bar magnet, okay, or if any magnetic needle is suspended freely on the Earth's surface, so it will never stay in horizontal direction. Okay, whenever a magnetic needle is suspended freely, so it will never stay in horizontal direction. It will make some angle from the horizontal, and whatever the angle formed from the horizontal is known as angle of inclination. Okay, whatever the angle formed from the horizontal is known as angle of inclination. Now, the part that is passing from geographic axis is known as geographic meridian, and the part that is passing from magnetic axis is known as magnetic meridian. This is magnetic meridian and this is geographic meridian. Okay, the part that is passing from geographic axis is known as geographic meridian, while the part that is passing from magnetic axis is known as magnetic meridian. Okay, and the angle formed in between geographic meridian and magnetic meridian is known as angle of declination. Okay, the angle formed in between magnetic meridian and geographic meridian is known as angle of declination. Okay, and if we divide angle of inclination in two parts, then we will get the horizontal components of Earth's magnetism as well as vertical components of Earth's magnetism, both we will get. Okay, if we will divide angle of inclination in two parts, we will get horizontal components of Earth's magnetism as well as vertical components of Earth's magnetism. Okay, now the next topic I will explain how we can define isogonic and agonic lines. Okay, so how we can define isogonic line? A line joins all the places on the surface of Earth. Okay, a line joins all the places on the surface of Earth having same angle of declination. Okay, this one is having the same angle of declination. Okay, having same angle of declination is known as what? Isogonic line. Okay, and a line joins all the places on the surface of Earth, okay, having zero. This one having same angle of declination. Having zero angle of declination. Okay, what? A line joins all the places on the surface of Earth having same angle of inclination is known as same angle of declination is known as isogonic, and zero angle of declination is known as what? Agonic lines. Okay, clear to all? Now, how we can define neutral point? Okay, so if so there are 2 points, 2 poles it is given, same poles. Okay, so here just see, magnetic lines will pass like that, it will pass like that. That means the space in between two opposing magnetic fields at which no deflection will get by the needle, magnetic needle, is known as neutral point. Okay, the space in between two opposing magnetic needles, that means just see, north and north pole both will repel to each other. Okay, and if in between them we are going to put a in between them if you are going to put a magnetic needle, okay, in between 2 bar magnets at the same poles, once we are going to keep a magnetic needle, then no deflection will get by the magnetic needle. Okay, why? Because 2 same poles are facing to each other. Okay, so the space in between 2 opposing magnetic field in which no deflection will get by the magnetic needle. Okay, that means magnetic needle is not going to set up in a particular direction. Okay, magnetic needle is not going to set up in a particular direction. Then this point is known as neutral point. Okay, another way, one more definition you can write it. If we take a bar magnet, North Pole, South Pole. If we take a bar magnet, okay, and nearby this one, if we put a magnetic needle, if nearby the bar magnet, if we are going to put a magnetic needle, then up to a certain range, the deflection will get by the magnetic needle. Okay, but once we are going to shift it more, once the magnetic needle is going to shift it more, then at a certain point, no deflection will get. At a certain point, no deflection will get by the magnetic needle. Okay, that means, try to understand in the easy manner. If we take a bar magnet and also take a magnetic needle, and if the magnetic needle is moving nearby the bar magnet, so we will get the deflection at each and every point. Okay, but at a certain point, okay, if we take a bar magnet, also take a magnetic needle, then if we will shift it, we will get the deflection at each and every point. Okay, but at a certain point, no deflection will get by the magnetic needle, and that point is known as neutral point. Okay, again listen. What? If we take a bar magnet, okay, then take a magnetic needle, okay, shift it, magnetic needle, okay, then at a certain distance we will get the deflection by the magnetic needle, but at a certain point there will be no deflection will get by the magnetic needle in a particular direction. Then such type of point is known as neutral point. Clear? Okay, now how we can draw the magnetic field lines? How we can draw the magnetic field lines? Take a bar magnet. Okay, already I have explained. Again I am going to explain. Take a bar magnet. This one is the North Pole. This one is the South Pole. Okay, take a bar magnet. Here, put a magnetic needle. Deflection will get. Okay. And exactly the point at which the magnetic needle it is going to stop. Okay, what to do it? You have to take a bar magnet. Okay, nearby the bar magnet, at one end of the pole, we have to put a magnetic needle. Okay, once we will put the magnetic needle, deflection will get by the needle. Okay, and exactly the point at which the needle it is going to stop, mark the point. Okay, the pointer position of the needle, just mark the point. And again, just in the direction of the point that you have marked. Okay, again listen. Again, you have to shift the magnetic needle in that direction in which you have marked the point. Shift in the direction, like that. Again, deflection will get. Again, we will get deflection. Again, we will get deflection. Again, we will get deflection. Then, every time once you will shift the magnetic needle in the direction of the point that you have marked, that will get by the pointer of the magnetic needle. Just mark these points, join these points. Here also join these points. Just like here at the top, in the above portion you have drawn the magnetic field lines, in the same manner also in the bottom portion you have to shift the needle from north to south pole. You will get again some points, and after joining these points we will get a line, and these lines are known as magnetic field lines. By this way you can draw the magnetic field lines. Okay, by this way we can draw the magnetic field lines. Okay, now I think most of the topics that I have completed, but see one or two topics more left, I think so. Isoclinic lines, and aclinic lines. Okay, isoclinic lines and aclinic lines. How can define isoclinic and how can define aclinic lines? Isoclinic lines are a line joining all the places on the globe having same angle of inclination. Okay, a line joining all the places on the globe having same angle of inclination is known as isoclinic lines, and a line joining all the places on the globe having zero angle of inclination is known as aclinic lines. Okay, a line joining all the places on the globe having same angle of inclination is known as isoclinic, and a line joining all the places on the globe having zero angle of inclination is known as aclinic lines. Clear to all? Okay, now already some points already explained to this some more points that I have explained. Why the temporary magnet is made up of steel, permanent magnet is made up of steel, while temporary magnet is made up of soft iron. Give the reason. Okay, why permanent magnet is made up of steel while this temporary magnet is made up of soft iron? Okay, why magnetic field lines are never crossed to each other? Okay, then properties of power magnet. All the things are already explained. Okay, again I think there is no need to explain these things, that how we can define it and how we can differentiate between the temporary magnet and the permanent magnet, how we can define the properties of magnet, how we can define isoclinic line and aclinic lines. These things already explained. Now see some more topics that is given in exercise questions. Just I want to take some question from the exercise. Just see from the question bank it is given. Why do lines of magnetic forces never cross? Why do they never pass through a neutral point? Okay, so two magnetic lines can never cross to each other. Already I have explained. Two magnetic lines can never cross to each other, never intersect to each other, because once they will intersect to each other, in this condition it will show two direction, and once it will show two direction, and in this condition magnetic field will be not decided in which direction the direction of the magnetic field will be there. Okay, two magnetic lines can never cross to each other, two magnetic lines can never intersect to each other, because if once they will intersect to each other, it will show two direction. Okay, and the two direction of the magnetic field is impossible because always magnetic field is starts from north pole and ends on south pole. So two direction of the magnetic field, it is impossible. Okay, now the next question is given. Why do they account for the following facts? Iron becomes magnetized when placed in a coil carrying direct current. So once this is the page number 223, it is given. Page 223, question bank. Second A. Iron becomes magnetized when placed in a coil carrying direct current. That means once the direct current we are going to use in a current coil conductor, and in this condition after passing the current it will behave as a magnet because all the molecules of the iron, it will be arranged in a chain, and once they will arrange in a chain, then 100% it will produce the property of bar magnet. Okay, now second B part, it is given. Bar magnet lose their magnetism when heated strongly. Okay, already I explained that once the bar magnet, it is going to heated strongly. Okay, once the bar magnet is heated strongly, then already I explained that in the magnetizing property, all the molecules of the magnet, it will be arranged in order. But once we are going to heat strongly, then in this condition the chain of the molecules, it will disturb, and once the chain of the molecules, it will be disturbed, then in this condition it will be easily demagnetized. Okay, so again listen, what if a bar magnet is heated strongly, then in this condition it will be demagnetized. Why? Because the thing is that once we are going to heat it strongly, then in this condition the molecular chain will disturb. Okay, the molecular chain of the bar magnet, it will be disturbed, and once it will be disturbed, so molecules will randomly move here and there, and once they will randomly move here and there, then in this condition it will be easily demagnetized. Okay, now C part. What is given? Steel makes better permanent magnet than soft iron. Okay, steel makes better permanent magnets. Okay, so how the steel makes better permanent magnet than soft iron? Because once we are going to magnetize any steel, okay, so the molecules of the steel, it will be strongly moved towards the direction of the bar magnet, as well as it will be systematically arranged. Okay, it will be systematically arranged and it will be strongly arranged, and if once you want to break it, so you can't break it easily. Okay, once we are going to magnetize a steel, then in this condition all the molecules it will be strongly arranged. Okay, and easily you can't break the chain. Okay, that's why steel will behave as a permanent magnet. Now come to soft iron. Soft iron, once we are going to magnetize it, so it will be arranged in the chain. Okay, it will be arranged in the chain, but the movement, it will be very little bit less in comparison of steel. Okay, that means the force of attraction between the molecules, it will be less in comparison of the steel. That's why you can easily demagnetize it. Okay, you can easily break the chain of the soft iron. But you can't easily break the chain of the steel. By this way, you can say this thing, steel makes better permanent magnet than in comparison of the soft iron. Clear? Okay. These are the some questions that you have to see it. Now, I think so all of you have got all the things, and as well as also all the chapters completed. Now again, I want to remind the syllabus one portion once more. Chapter number 1, only first 2 units you have to prepare. Okay. Chapter number 1, only first 2 units from chapter number 1, only first 2 units you have to prepare. Then rest of the units no need to see. Then from the graph, no question will be asked. Then after that, all the chapters you have to see. Then from chapter number 7, energy flow, no need to study. Chapter number 7. Okay, chapter number 7, energy flow, no need to study. Okay, energy flow, chapter number 7, page number 138 to 155. No need to study this chapter. Then the diagram of the 14th barometer as well as Android barometer, it is not there also in your syllabus. The reduced syllabus already I have told to you. Now, portion will be also like that. The ratio of the third semester or the final exam portion from last 3 chapters, maximum things you have to prepare. Okay, from the last 3 chapters, maximum things you have to prepare, and then few questions also from the first 7 chapters, 7 to 8 chapters. Okay, by this way you have to prepare. Okay, I hope so all of you have got all the things. Thank you to all of you and best of luck for the annual examination. Thank you to all of you.